Hi, welcome back to Microeconomics YouTube channel. In this class, we'll be introducing ourselves to the concept of statistics. Although I think I should say before now that some classes have been doing on statistics already, but then there is this need to kind of let's try to just have a video that introduces us to the concept of statistics in the very first instance. It's a pretty much simple thing, but there are some concepts that I'll be discussing in this particular video that would be required to understand in subsequent statistics classes. Let's just get the foundations right. All right. So, what is statistics? So, statistics is basically, the science or a branch of mathematics that deals with the collection of data, the analysis of data. In your analysis of data, of course, you need to do classification of data. And then you have interpretation of data, then presentation of data. So basically speaking, statistics is about data. So the collection of data, what you do with the data, and then when you finally present, the data and whatever conclusions you've drawn from the data, you talk about all of those things. All right. So as a formal definition, so statistics is the science or a branch of mathematics that involves the collection, the classification, the analysis, the interpretation, and the presentation of numerical data. Okay, so going from there, we then have what are the branches of statistics? They are basically two. So you have descriptive statistics. Descriptive, from that word, it means to describe, and then we have inferential statistics, to make inference or to draw inference from. All right. So descriptive statistics, that one is the easier one. It's basically the branch of statistics that deals with providing a summary about a particular data set. All right, so descriptive statistics is trying to describe a given data set, a given set of numbers. So maybe you've gone on to get a data on the number of maybe black students in foreign universities, for example. So then you kind of describe, okay, in what universities you have the most black students. So that you'll be talking about the mode, right? And then maybe you want to look at other aspects of what they're doing, like what are their scores, how are they performing, in the respective universities that they are in. Okay, so it does, a way of just trying to like let us, a data set is just like it could be like a pile of rubbish, if you don't attribute meaning to it. So um we have descriptive statistics trying to like bring out the meaning of all of the data set that we have. So it kind of focuses on the central things. It provides a summary of the key parts of a particular data set. So and under descriptive statistics, we'll be looking at the mean of the data set, and we'll be looking at the median, all of those measures of central tendencies and the measure of variation. Okay, mean, mode, median, standard deviation, your variance, so on and so forth. So you have a data set and then you have to look for all of those things. Or then you want to just try to make meaning of these things and then you just talk about, all of those data. Now you might be given a GDP data, for example, of a particular country over a lot of years. Okay, looking at the gross domestic product of a particular country over a lot of years. And so, what is the average GDP? Okay, and then what is the highest? Looking at the range now, looking at the highest minus the lowest value. So, what's the range of the GDP of this particular country? That is, you kind of try to identify the year it had the highest GDP, and then the time period, or maybe the year if it is measured in years, and it had its lowest GDP, and then you do a subtraction and then you get an answer. So that's the range. Then has it been having, maybe I don't know, maybe a particular, maybe some years it's kind of had a constant, what do you call it, a GDP value, which is kind of weird and rare. Now okay, you have like exact GDP value of 2 billion, 2 billion, 2 billion, maybe five times in a particular year, in a particular, within in a particular scope of data set. So let's say between 2000 and 2020. So it kind of had the same value in about maybe 5 to 6 years. So you'll be looking at the mode in that aspect. Then you have the median as well, and so on and so forth. Okay, so all of those things they are trying to provide summary of a particular data set. So that is what descriptive statistics is really about, trying to tell you the features of this particular data set. Now from there we now move to inferential statistics. So which is the second branch of statistics that tries to verify the conclusions that have been drawn on the population of it on the population of a data set from a sample. Okay, so the thing is that I think I already spoke about that in another video anyway, elaborately. So population refers to, which is what I kind of have it here. Population refers to the entire data set of a particular variable. Okay, the entire data set of a particular variable. While a sample is an extraction from the population. Okay, so we could be looking at number of, okay, I think okay, one of, okay, let's see, we're trying to look at the eating habits of black Americans. No, the eating habits of blacks in the whole world. The eating habits of blacks in the world. So that means we need to get a population of every black person in the whole world. That may be somehow. Then after getting the population, then you need to start getting data on their eating habits. So that may be crazy to do. So it may be impossible to get the data. It may be difficult to get the data. And then even if it's not impossible and difficult, by the time you eventually get the data, it may be so Herculean to work with. Do you understand? So like looking at blacks in the whole world, that's like population. Okay, then because of the kind of analysis that you want to carry out, you can say, okay, I don't think I can work with the population of the entire blacks in the whole world. That might be too much data to work with. So let's just look at let us draw a sample. You understand me, from different countries, then just draw a sample, maybe like 1,000 persons. So instead of a value that might be running into maybe billions of people or hundreds of millions of people. So let's just draw a sample, 1,000 there, 1,000 there, 1,000 there. You understand? So those things that you're trying to draw out, they are samples, they are extraction from a population. So when in statistics, okay, under inferential statistics, for example, there's something that we need to note from the beginning, that the sample that we are drawing, because maybe we don't know the population, we can't know the population. Don't let me say we can't, we don't know the population. The sample that we are drawing must be representative of the population in question. So that's not an issue of this particular class. We are just introducing ourselves to one thing or the other. So whatever summary measure that you get from a population is then called a parameter. For example, if you were to get the mean number, the average number of blacks, okay, in okay, in the whole world. Okay, or should I even put it that way? Let's talk about a class, for example, or let's talk about a class. Okay, so and you have their test scores, and then you want to get the average test score, for example. So we are looking at a class, just a class. So like that can be our entire population if those are the only students in the whole world. Okay, so we look at the average test score. Since we are talking about the population, right, that is the entire number of students. Let's just assume that there are 20 in the whole world, just 20 students. So looking at their test scores, then the mean of the test score is a parameter. So the mean is trying to give you, the mean is a measure. Okay, that is it's trying to it's falls under I think falls under descriptive statistics. It's a measure. Do you understand? It's trying to like summarize this data set for you. Okay, so by the time you get that mean, for the fact that you were dealing with the entire population, you were dealing with the entire data set of the variable that you're looking at. So we say that you have a parameter. Okay, but assume that we have millions of students and then you want to check test scores on a particular exam, and you only get to use 20 students out of the millions of students that you have that probably did that exam or something like that. So the 20 students that you're using in this case now would be a sample, because you're not considering every data involved, right? It will be a sample. So in this case, if we were to calculate the mean, that would be a statistic. Do you understand? So where is it? So which is what we have here. So if you calculate the mean, so the mean is providing we are looking for mean for the two of them. For the first one, we were looking at the mean of a population. Okay, then you got a parameter. So like that's a mean. So the mean of the population is an example of a parameter. Or if you're looking at the mean of a sample, and that is an example of a statistic. So that's just the difference. So parameter, whenever you're dealing, is not always mean. It could be anything. It could be the mode. It could be anything. So whenever you're looking at a measure that is drawn, okay, from a population, the name of that measure is it is a parameter. And if we're using a sample, then it is a statistic. All right. So inferential statistics is not like, okay, the conclusion that you've been able to draw from using a sample, okay, is it reliable? Does it really speak the truth about the population, that we are trying to like make reference to, that we are trying to talk about. So if the is the conclusion on when we were trying to conduct a research on the eating habits of blacks in the whole world. Now we've drawn samples from different countries, 1,000 blacks, okay, from different countries, and we couldn't use the whole data for one reason or the other. So if your conclusion were to be that they feed well, or maybe these people don't really feed well, they are malnourished and all of that. So that conclusion, is it reliable? Is it a true conclusion by the time you begin to no, is it representative of the entire population of the black race? So that's what it is talking about. That's what inflation statistics fall under. Is it representative, of the entire black race in the whole world? Okay, so inflation statistics is more or less a step further away from descriptive statistics. Descriptive is just like, okay, this is the data set. We're looking at a set of people. This is the data set on a set of people, and these are their distinctive features. This and that, and that to tell you, like a human being, he has a hand. He has a leg, he has two legs, he has two arms, and so on and so forth. He can walk and all of those things, right? Then differential statistics is now, taking you further than what is obvious, from the present data. So is it representative? What you are saying of this, the conclusion you're trying to like explain, you're trying to tell us from this sample, is it representative of the entire population at the end of the day? So by the time we keep studying, then you are going to begin to understand some of these things properly. Descriptive is very easy to understand. It is differential that may, it's also easy, but it's just a step, away from this. Here we'll be looking at the class intervals, for example. Then you start looking at conducting different type of tests, your T test, your F test, your whatever. When we get there, we are going to like talk about all of those things. So then variable. What then is a variable? Okay, a variable is a characteristics. A variable is a characteristic, okay, that is measurable and then can assume any value. Okay, a variable is a characteristic that is measurable in one way or the other and can assume any value, and then changes from observation to observation, or changes from, if you're observing people, changes from, one person to another person. So a variable is a characteristic that is measurable and then changes from observations to observations. Okay, basically speaking. Then income, for example, is a variable. Okay, and the one that you probably been used to before we got to this point is variable x, variable y. And by the time we start assigning values, you see a variable x is going to take on several values, and then variable y2 is also going to take on several values, right? And usually, when variable x is changing, variable y2 is going to be changing depending on the relationship that you have between, the two. So that's if we were to look at a model or an equation or a function or something like that. All right. So under age is also a variable, right? Age is a variable. Anything can be a variable. Do you understand? It can be a variable. So age can be a variable. Income can be a variable. Height of people can be a variable. The type of phones that people use can be a variable. Books that people read, the type of books that people read can be a variable. Like, do you understand what I'm trying to say? Okay. Then under variables, we now have two types of variables. We have the qualitative variable, and then we have the quantitative variable. So qualitative variable is basically non-numerical variable, right? It's also known as categorical variable. So the qualitative variable more or less just defines things in terms of categories. Like it breaks things down into categories. Are we following? So an example of a qualitative variable, I said non-numerical. Okay. An example of a qualitative variable is gender. So when you're looking at gender, usually, or I don't know. So we basically have two. So we have male and then we have female. So like, can you is male, is it numerical? Like, is it a number? It's not a number, right? Is female a number? It's not a number. So that kind of way. So gender, the broad category, okay, is a qualitative, variable. Then we have color. Red is not a number. It's not numerical. Blue is not numerical. So color as the umbrella is a um, qualitative variable. Then we also have size, big, small. You see, so size, then under size now have different categories. So we have big, small, medium, right? So those are not numerical as well. So those are the things that fall under qualitative, that are examples of qualitative, variables. They are also called categorical variables, remember, and they are used to um, classify in different categories, or classify things into different, categories. Now, quantitative variables are, numerical, variables. You can assign, they take on numbers, right? For example, age. Okay, we can say 15 years, and then we can say 40 years. Obviously, that makes sense. 40 years is more than 15 years. Okay, you can say someone is 15 years, someone is a 15-year-old boy, and then you have a 40-year-old man, right? Then time. Time can also, you have 5 seconds, 10 seconds, 48 minutes, 2 seconds, and whatever. That is also a quantitative, variable. Then years of schooling. So how many years did you spend in school, right? So you can have, you know 40, no, it's 40. Okay, 6 years, 10 years, 11 years, and so on and so forth. So these are examples of quantitative variables. So you can't say how many gender are you, that doesn't even make sense as a question. And you can't say how many color are you. Okay, well, but I think you can say how many colors are there. Okay, but I don't want to, begin to confuse myself and then confuse the, audience. Well, how many years did you spend in school? It's 5. Okay. Okay. How, how long did it take you to get here? So in terms of time, 15 seconds, 2 minutes, whatever. So, how many sides are there? Big, small. Okay, so just kind of note, these things that quantitative variables are numerical. They primarily take on numbers, right? And qualitative, they are numerical variables. So under our quantitative variables, we then have two other categories. We have discrete, variables, and then continuous variables. So discrete variables are variables that are used to count. Okay, you use them to count. And then continuous variables are variables that are used to measure. Now, a trick that people usually use is that your discrete variables, they take on a they take on an integer. Okay, they take on, a particular, they don't have decimals, right? They don't have decimals. And then continuous variables, when you are measuring, they can take on decimals. They have decimals. They have decimals. Now, for example, age, okay, will fall under discrete variable. So you can count the number of years that someone has lived, right? So he lived for 30 years, he lived for 20 months, in case a child that, that became whatever, that just didn't live for so long, then he lived for 100 years. So all of those things, they come under your discrete variables because you can count them, right? But when you're looking at continuous variables, example, height. Can you count your height? So you measure height, and when you're done, you can say you're a 5, is it 5'7", 5.7, whatever. A 6, I don't 6'1" man, 6'2", all of those things, the way people say them. So you can't say that you are counting height, you measure height. Are we following? And at the end of the day, you're going to be getting a decimal number, maybe 6.1, whatever. Then you also look at weight. Okay, weight also falls under a continuous variable. So a continuous variable. So trying to measure the weight of somebody, if you are 5.3 kg, 50 point something kg, trying to measure the weight of something, right? So all of those things, you measure them. You don't count weights. Okay, you don't count height. You don't count time. So time is an example of a continuous variable. You measure time, right? So all of those variables are used to measure. They fall under continuous variables. Variables that are used to count, right? They are examples of discrete variables. So I think with that, I think that's a bit. I think, is there something else? If you have questions, you can leave them in the comment section. So I think we are done with this particular part. So the next now we're going into is I think sample design or something like that. So I'm see you there. Bye. Have fun.